Hello and welcome to Computerized Engineering. In this tutorial, I will walk you through two softwares that you can use to do topology optimization like this. Both of these softwares are absolutely free to use. Let's have an overview of the process from a presentation that I made. So this is a basic tutorial for topology optimization using Z88 Arion, if I pronounce the name correctly, and FreeCAD. The first thing you have to do is, of course, download the software if you already haven't done so. You can find these links from the description. Additionally, you can also find the link for this presentation in the description. To make sure that this is a beginner-friendly tutorial, I came up with a very simple design problem. We will design a plate which will be fixed from these two faces over here, and then we will apply a load of 10,000 newtons. And let's suppose there is a design requirement that we have to keep these two faces. So we will also learn how to exempt certain areas from optimization. We will use FreeCAD to create the geometry and also to do the meshing. This is FreeCAD over here, and here you can see that I have prepared the geometry and also did the meshing. Then we will continue rest of the work in Z88 Arion, and both of these softwares are very easy to use. And lastly, if you like my content and you want to support the channel, you can do so by finding this link in the description, which will redirect you to this page. Here you can do any amount of donation that will help me to grow the channel. So without any further ado, let's get started. So once you have downloaded and installed FreeCAD, you will see the start page. Just go to empty file and in tasks, go to create body, create sketch, choose front face over here and begin your sketch on XZ plane. So we have to create a plate over here, and in order to do that, let's choose create polyline. And let's create a few lines like this. Press escape and continue from here, something like this. Press escape again and again. Now we will connect this using this arc over here, which is create arc by 3 points. So do that like this, and now let's make this horizontal. In order to do that, click here and then choose this constraint horizontal / vertical. And we also have to make sure that both of these lines are collinear. So select this point, and then choose constraint horizontal / vertical. Make this vertical and make this vertical as well. Also make both of them equal and give a tangent relationship here and here. So now we are good. Now we have to give rest of the dimensions. So this is 300 and this is 200. Press escape and let's drag this all the way over here. And let's assign this dimension. So this should be 15 millimeter. And this line is 20, and from here until here this is 20 as well. Now we just have to create circles over here, so we will do that using this option, create circle by center. So create a circle here and one over here, select both of them and make them equal, constraint equal, give this dimension 10 millimeter, and let's make sure that they lie on the same line. So select the center of this circle and the center of this circle, and then choose this option, constraint horizontal / vertical. Now you can see they are on the same line. Now we just have to give dimensions on the top, so 20 and 20. Now only this circle is left. So this is from here until here 20. Now our sketch is fully constrained. Just close the sketch and go to model. Make sure the sketch is selected and then choose this option, pad. We have to give a thickness of 10 millimeter. So make sure the length is 10 millimeter and click OK. Now we have created the geometry, and the next step is to mesh this. So in order to do that, just open this drop down menu and go to FEM. Here you can mesh using two options. So the first one is FEM mesh from shape by NetGen and FEM mesh from shape by Gmesh. I will make a separate video where I explain the difference between the two, but for this tutorial, let's go ahead with this one with NetGen. So right now you can see these options are deactivated and you cannot select them. First, what you have to do is select the body that you have to mesh, and in our case, it's this one. So once you click over here, now you can see these are activated. So let's select this one and let's keep a coarse mesh and make sure this is not second order. So let's create a size that will allow us to have nodes in the middle as well. So since the thickness is 10 millimeter, I will choose a max size of 5. Click apply and wait for a little bit. Now you can see we have some nodes in the middle. You can mesh this according to your preference. I'm just making a quick mesh for the tutorial. So once this is done, click OK, and now we have meshed the plate as well. Now the next thing what we have to do is just save the mesh file. So click on this mesh file over here and go to File, Export, and let's save this as uplate.inp. Here you can see you have different FEM mesh formats, and for this tutorial let's go ahead with .inp, which is for Abacus. So click Save over here. So now we are done with step number 2, and let's have a look at step number 3, which is to do the setup in Z88 Arion. And this software can be downloaded using this link, which you can find in the description. It's very simple to download and install. And once you do that, you can open it. Just type Z88 in the search bar and click over here. So I have this already open. Let me close this one and open a new session. So let's close this. You can open the software, just click over here and it should open. So before we begin with the software, just let me tell you about the workflow that we will be doing. So the first thing that we have to do is create a new project. Once we create a new project, we will import the mesh that we just created, and then we will move on to pre-processing, where we will define the material, select the nodes, and then define those nodes. And finally, we will set up solver settings and run. Now, after you open this, I think this will be in German because the default language of Z88 Arion is in German. So unless you speak very good German, you will have to change the language. So go to Tools, Options, and in General, here you can change the language to either German or English. So once you have your preferred language selected, just go to File and New. Now, there's one thing that you have to make sure. Make sure that you create the project where you have installed Z88. So for example, I have this installed in D drive in this folder. So go to Win, and over here, let's create a folder. Let's call this uplate opt. Hit enter, and while you are in this folder, just click OK. Now we will import the mesh file, and in order to do that, just click over here, import, or you can go here as well, import. So click here, and we saved the mesh file as .inp. So I will choose Abacus file over here and find where you saved the mesh file. So for me, it's over here, and click OK. Now you can rotate and pan the screen. If you press right mouse button, you can do this. And if you press left mouse button, you can do this. And you can change the display from here. So you can view the surface mesh or the mesh itself. So let's go ahead with surface mesh. And look, let's have a look at the next step, what we have to do. So now let's move ahead to pre-processing and let's define the material. So you can click over here, pre-process, and you can also check the quality of your mesh. So if you go to tetrahedrons and you go to mesh info, it says the mesh is computable, which is good. So let's close this and go to preprocessor again. So first of all, let's assign the material. And for this tutorial, let's go ahead with engineering steel. So once you click over here, just click define. You have successfully assigned the material. And now you can close this. Now the next thing what we have to do is pick the nodes. So click here, and once you open, you can zoom in and you can see how these nodes have been highlighted. You can change the size using this button. You can either decrease this or increase this according to your preference. So first, let's go ahead with selecting the nodes that will be fixed. So let's zoom in over here a little bit more, and you can select the nodes by pressing and holding the control key on your keyboard, and then click on this node using the left mouse button. Once you do that, you can see it turns red, and just click on surface and you can see it selects all the nodes on this surface over here, and then click add over here. Deselect everything, and let's now select the nodes over here. Again, press and hold control and then click on any of the node over here using left mouse button. You can see this turns red. Surface, all of them are selected, add. Now let's rename this so we can keep track of this. Let's call this hole 1 and hole 2. Now select both of them using a control key and add set, and let's rename this set to fixed support. Hit enter. Okay. Now before I go any further, let me tell you about this angle option over here. Now let's suppose you don't have to follow me here. If you press Control and click on any node over here, and let's suppose you decrease the angle to, let's say, 3.5, and then you click surface. Now you can see it selects lesser nodes, and the reason for that is if we have a look at the manual, which is over here. This link is also available in description. If you click over here and go to Z88 Arion, you can download the user guide, which is in German. So you will have to speak very good German in order to read this. Let's keep this, keep anyway, and let's open this file. And the thing what I want to show you is somewhere over here. Yes. So here you can see how you can select different nodes, different set of nodes depending on the angle. So if the angle is 1, it's like this. If it's 40, you can select it all over the geometry. And if it's a very low number, you get nodes selected like this, and so on. So you can go ahead, play with it, and see which angle is most suitable for you. So let's deselect everything and let's zoom out a little bit. And now we will select the nodes on which we will be applying the load. And in order to do that, we have to again press and hold Control, click over here, wait for it to highlight. Okay, if it doesn't happen, click again. Let's increase the node size a little bit. And again, we will select a node over here. So press and hold Control, and using your left mouse button, click over here. And once this is highlighted, let's increase the angle to, let's see what happens if we keep this at somewhere around 15. So click Surface, and you can see it has selected these faces. There's one additional thing that you can do. So let me show you another way. Let's deselect everything and select a node over here again. And this time let's increase the angle to, let's say 34. Surface. Now you can see it has selected all of these nodes. The other thing that you can do is, let's first align this. Yeah, okay, like this. Zoom in a little bit. So the other thing that you can do is make a selection box over here, and in order to do that you have to press and hold Shift key. And once you press and hold Shift key, using your left mouse button, drag a box, and you can see it appears after a while. So after you release it, you can see the nodes have been selected. So let's go ahead with this selection and add this, and let's call this force face. Okay. Deselect all, and now we have to select the faces that we do not want to optimize. So in order to do that, what I will do is press Control and select this node over here, and let's decrease the angle to, let's say 6.3 and see what happens. Surface. Okay, this is good. So let's add this, and let me select the second face over here, deselect all, select this node over here, surface, add. Now click on this force face over here and add set, and let's call this load. And the next thing that you have to do is select all of these. So hole 1, hole 2, force face, mark 4 and mark 5, and create a set over here, and let's call this not opt. That means we do not have to optimize this, so hit enter. Okay, now delete all of these and let's just have a quick look at them. So load, not opt. Okay, yeah, this is good. Now you can close this. Now the next thing we have to do is define these nodes. So go here, define, and let's start with the fixed support. So click over here, fixed support. You can see this has highlighted the nodes over here. Now we have to fix this in all the directions, so X, Y, Z, and we will fix the displacement and give this a value of 0. And let's create a name over here. Let's call this fixed support again. Hit enter. Okay. Now let's select the second set on the list, which is this one, load. So we have to give a load of minus 10,000 newtons in negative Z direction. And you can see over here the Z direction is like this. So we have to apply a load in negative Z direction. So make sure that you have Z direction selected and go to surface load. And let's give a value of minus 10,000 newtons. And let's give this a name. Let's call this load nodes. And the last thing on the list, the nodes that we do not have to optimize. So all of these nodes where we have a boundary condition, and including these ones, which you can say is a design requirement. So once you have this selected, go to this option, fix set, and let's call this not opt. Okay, done. Now if you go back to constraints, you can see you have the fixed supports, you have the load nodes, and you have the nodes which you do not want to optimize. Now let's have a look at the last thing on the list, which is to just set up the solver settings and run. So in order to do that, click over here, this calculator icon, which is the solver. So once you are in the solver settings, here you can see you can choose from optimization methods. You have three options. You can change the relative target volume in percentage, and if you open the optimization parameters, here you have number of iterations, optimization methods over here, simp and ramp, and a bunch of other settings that you can keep according to your preference. For this tutorial, let's go ahead with this one, and we only want to keep 25% of the mass, and let's keep the number of iterations at 100 and click OK. Now you can start the calculation by clicking on this button. You can see this window appears over here, which might also say not responding, but that's not true. If you open this window, here you can see that it's actually doing the calculations. So right now it's on third iteration, and now it's on fourth iteration, and so on. I will pause the video over here and then return when the calculation is done. Welcome back, and here you can see that after 100 iterations the calculation has finished, and it says over here smoothing successfully finished. So let's close this. Solver info ran successfully. Let's close this as well, and now let's move ahead to the post processor, which is this button. So click over here, and here you can see this is iteration 0, 1, and if you press the down key on your keyboard, you can kind of animate this, and yeah. So let's have a look at the last iteration, which is this one. You can also view the smooth surface if you click over here. Just click OK, and this will open a new window, and here you can see you have the smoothed surface, and you can save this. Just click over here and save this in a folder where you can find it later. So let's call this uplate stl and save it over here. So once this is saved, we will open this in FreeCAD and make a drawing on top of it. So I'll show you how it's done. So just go to File, Open, and let's find it where we saved it. So for me, it's over here, uplate stl. Just open it, and here you can see you have the smooth surface stl. Now we can draw on top of it. So let's see how we can do that. Let's begin our sketch over here, and you can create a rough outline. Once the part is generated, validate its mechanical performance using the FEM Workbench in FreeCAD to ensure that it meets your expectations. So first, let me tell you how you can create a rough sketch on top of it. For example, let's start with this one, create polyline, and you can create a rough sketch over here, something like this. No, I'm just quickly doing it for the sake of tutorial. You can go ahead and add more details. For example, if you just delete this and instead of this add a 3-point arc, you can create something better and make this tangent. Make this tangent as well. You know, something like this. And let's do that on this side as well. So let's create an outline now, something like this. Now, to make sure that this aligns perfectly, what you can do is create a rectangle over here using construction geometry. Something like this, okay. And let's give this dimensions. So this should be 200 and this should be 300. And this line from here was 20. And now you can see this part of the sketch, this is defined. So I think this is fine. You can go ahead and close this sketch, and let's hide this. Select this sketch and let's give this a thickness of 10 millimeter. So now you can go ahead to FEM Workbench and validate its mechanical performance. So that's all from this video. I hope you enjoyed it and see you next time.